Hey up everybody, and welcome back. Well, as you saw from the title, today's video is a GreeBSA experiment. So, a little preamble. As you know, well certainly if you've been watching me for a while, I'm not really an expert at this. I have some minor skills, but basically it's just in my final years I managed to put together the workshop I always wanted, and I have the time to play around and do the things I enjoy, and I take you along for the ride. So I make mistakes, but I always look on mistakes as being a lesson. So between us we've managed to see a lot of things that that's not the way to do it, but I think we've always found out, but this is how you can do it. So today is a video like that. So I'm going to move out the way and show you the GreeBSA and do a little bit more preamble. Sorry for all the chat. So there is the GreeBSA, which, as I mentioned, I really enjoyed riding. You'll also remember that when we built it, there was discussion about having the floating front brake. Now I'm going to show you some things closer up which will explain the thinking at the time. But basically, when I finished this, in order to finish it, I pinched the rock shocks off the greaves, off the standard greaves, to get this finished, because we put telescopic forks on it and I really didn't like the way it rode. I don't know if Greaves changed the general geometry of the frame for when they put telescopics on, but it didn't ride well at all. Certainly didn't ride as well as the standard Greaves. So I repaired the bottom of these to be able to put these on, and as I say, I stole those off the Greaves to try it out. Well, now I've got the new rock shocks on the Greaves, so I was actually able to compare the two suspensions. So as I say, this works fine. So it's going to work really well, I think, later on. But anyway, if I put the brake on and just push forward, as we mentioned, the wheel goes up. If I push down, I mean, the suspension works when I'm riding it, it works. But if I just put the brake on and push forward, it rises. Now at the time I said, well, we'll try it this way, and if it's not right, we can always change it later on. So let me bring in the real Greaves, if you like. So let me move that right out of the way, because I want this to be in frame the same. So now then, here's the real Greaves. Okay, this has a floating brake plate. Now if I put the brake on and just push forwards, see, we have suspension. So obviously I've been riding that around with really poor suspension action, and yet it still rides nicely. So with this on, it should be even better. So let me move this out of the way. Now I use TY wheels front and rear because the Greaves wheels have big hubs and chromed rims, so we were saving a lot of weight. But also actually because I only had one good front wheel out of the two of them. The other wheel, the rim has got a really bad flat spot on it and the spokes are rusty. So I don't know, this wheel cost me $100 altogether, just over. A new rim and spokes would have probably cost me $350, and that have been using the big old heavy hub. So that's why we went to this. Now this fixed plate means that the side of the fork is pressing on, well, there's actually a spacer, is pressing on the brake plate, which is pressing on the inner race of the bearing. Then there's a tube through, and pieces on the other side that press on the inner race. So when this is all tightened up, the inner race of the bearing is being trapped, so the hub turns with the outer race. So I did have one comment, why don't I just bore this out so that this plate, you know, put a sleeve in to carry the axial load when it's tightened up, but leave this to pivot on that bush. Yeah, that's fine. But what you also need to have is here the brake cable end is fixed. You've got to have the brake cable end on the brake plate. This is a magnesium brake plate. I can't weld onto it. So I actually bought this because it was nice and cheap, but it's too big. This would have been really nice if I could have fitted it, but as I say, it's too big. These are quite small hubs, but that was the sticking point. I couldn't put that on. So when I realised we needed to make this floating, I started to think about it. As I say, I thought about this. I searched, working off part numbers for the brake shoes. I actually thought it's a DT250. From the part numbers, there were only one number out, and I thought it was the width of this and not necessarily the diameter, but it's completely will not fit. So the other thing I thought was, I'll put a disc brake in, and what I'll do is I'll have the caliper like the back calipers, which floats on here, and then the tie arm, so the plate the caliper's on will be floating with the wheel. Well, that's great. It would be really nice, it would be light, it would be a great brake, but it means a new wheel, a caliper, a handlebar master cylinder and hose. We're probably looking at $400 to do it. So I have been racking my brain how to do this. And then I had a sudden thought. How about if I make the cable mounting on a plate which, like the disc brake caliper mount, would pivot on here and then be fixed to that. This arm would be set up so it could pivot on it, but this piece of plate would be fixed, so it would move with the brake plate. And then we could put the cable on that. So, how to get the cable to it? Well, the next thing I thought was, okay, if I put this on the other side, which it is actually on the greaves, then the cable, instead of coming from the front, will be coming from the back. So we've still got some more thinking to do. I'm wondering whether if I take the brake arm and have it come out this way, what I can do. So I think we'll take the wheel out so we can start to visualise this a bit better from, I think, from the other side. Although actually, if I turn brake around so it's like that, the cable could be because I don't think it's going to be up. I don't think I'm going to be able to do it up. Anyway, let's take the wheel out and we'll start to think about it a bit more. Actually, now I've moved things around, it's starting to look a little bit more doable. I took the wheel out, turned it round, but you know, this wheel is designed to be on the left. So the engineers there have, you know, at Yamaha have thought about the way the brake shoes expand and all the rest of it. So as you'll see, I've turned that around. Now, we need to have, can you see that back piece here? We need to have a pivot point on here. So I had already, while I was sort of thinking about this, made this. And the idea was I was going to use, what I've done with it, why do I put things down and lose them? Good grief. Hold on. I'm back. I was thinking of using the original one of these. I still might. These have a 3/4 inch hole, and it just so happened that I had in my sort of bronze scrap bin a couple of 3/4 inch OD bronze bushes, and they're 1/2 inch ID. So I made up this little piece which would go on there like that and then get bronzed on. And that, see, the bronze bush is a tight fit on there. That would go on there, and that's how that would pivot. Now, how much space have I got? None there. So I couldn't put that there. But I could put that like that. Space up behind it to come up behind, because I have to come up behind to that. See, this thing has got this plate that it goes on, has got to be mounted in 2 places really. So if I could just weld onto this, it would be so simple. So what I'm thinking of, as I say, is I'd make a piece out of 1/4 inch thick alloy. The wheel spindle would go through it, and then it would be bolted tight to that. So it would just move, it would in effect become part of the brake plate. Then I'd have that on there like that. And if we made this thing a little bit L-shaped, have the cable there, and the cable could just come round like that somehow. Over the top even, see? But now I have the problem that I don't have enough space behind this . Do have enough space to put it on the outside. Just have a spacing piece there. Oh! I have a spacing piece there. Let's see what goes on. That sticks out enough. Just an L-shaped piece of 1/4 inch alloy. We make our piece that goes in here. So that this pivots, the spacing piece that will go in the middle. See, the 1/4 inch plate will tighten up onto the pivot, and that'll still do that. Now then, on the greaves, this is, I think it's 3.5 inches. That is vertical to above, basically vertically above that, and this pivot is vertically above this, right? And then I think I'll measure them again, but I think that was 3.5 inches, and this was 2 3/4. I'll measure them again, but we'll try and keep and this distance was the same. The distance from wheel spindle to that pivot point was the same as the distance from there to the pivot point at the back, or I think within 1/4 inch or something like that. Because when that goes up, that needs to be able to pivot forward. We'll have a look at the greaves to see exactly how the mechanism works and take some more dimensions. But I think that will work. L-shaped piece of alloy, we'll put the cable mounting point on the back of it so it gives us a straight pull. Yeah. Cable wants to be pulling basically at right angles to this. I think that'll work. And we only have one piece of bronzing to do on the back of here, which we can do in situ. We'll just disconnect the electronic ignition, which I always like to do. Alright, let's go and look at the greaves, how it works. Now I can't actually get you down level with that. I suppose I could stand the camera in the box or something. Hopefully we'll be able to see from this. So the weight, the brake plate stays exactly where it is. And that's why this has got to be a parallelogram. Okay. So let me just measure that to there, that to there, that to there, that to there, write them down on a bit of paper. Now we're not working on absolute measurements here, but relative measurements because, oh Laurie, because of course we've got a different size brake plate. But there to there is the same as that pivot point to that pivot point on that one. It's 8 5/8. There to there is 2 3/4. There to there is 3 3/8. So it's not actually a perfect parallelogram. If we take that as being the base and those as being verticals, then that top one is actually at a slope. So let's see what we've got here. This bottom, well, this bottom one should be the same. It's actually reading 8.5, but we know we had to remake these, so that could be an 8th difference. So what we need is 8.5 for that, which is what it is, right? Because that's the original one, so that is right. Now what we have here though, and I might get my head in the way here, is 3.5. So it's actually a good bit more than that one. So that back one is about a ½ inch higher than the front one. So basically, if, as I say, that is 3.5, that wants to be 4 inches. 4 inches up, and it's virtually vertical. So excuse me again. So it actually wants to be up around that line somewhere, like that. That doesn't look right. I'm going to go and check these measurements, but that does not look right. that would be $8". And we need it to be 8 5/8. Oh, don't tell me I have to remake that to move it back. But anyway, let me go and check on the greaves again. Alright, anybody spot the mistake? My measurements were right, but I was looking at this from this side. So that is the front measurement, and that is the back measurement. So 3 3/8, and what did I say this was? 3 1/2? That's only eyeballing it. It might be 3 3/8. So that only wants to be about there. Still reading 8 inches. Oh, hang on. That wants to be to the centre of that. Yeah, that's still only reading 8 inches. No, we can't move that. So, that needs to be further back. Bugger, I was so pleased with making that look. I even did little autogenous welds. I used the pulse, it worked fine. That is such a bugger. Oh, actually, no, I might be able to do this. Let me go and get a magnet to hold that in place. Well, that is exactly spot on. I just popped a bolt in there. We'll have to fiddle on a little bit, you know, bend and straighten this, but that's above that, that's above that. All the measurements are right, and that's nice to bronze on there. So that will work. So we have to make up a piece here. So we're going to have a little 1/2 inch piece, got to have the bronze bush on it. It's got to go in this way because there's a captive nut on the back, and there's very little space for the bolt to fit through, or it catches on the spokes. And you can't put it in from the back over anyway because of the spokes. So let me design that thing and make that, and then it's got to have room for, which it's got here, a 1/4 inch. We're clear of the suspension unit, everything is fine like that. Then when we make that so it can all bolt up, we can bolt it in place, and that will hold it while we bronze that. I think that'll work. I think that brake cable will be fine up there. It's not going to get in the way of anything. Alright, let me work out how big that piece has got to be there. Right, so I've made the pivot point with its bronze bush in. This bolts in tight, so we're right. So at the moment it's got a 1/4 inch spacer in it. You see the 1/4 inch spacer is tightened up by the bolt, but that's still like that. So I have to cut a bolt the right length for the back end. Hang on. Just have to cut a bolt the right length for that. And then we can bolt it up tightly, put it where it wants to be with the measurements, and then I can well, bronze one side, take the wheel out and bronze the other side, and then we'll make up our alloy piece for here. But that's with the thickness of a piece of 1/4 inch alloy in there, and there's enough space for this to move inside. So the alloy I'm going to weld to that spacer. We'll drill that spacer out to take a sleeve, and we'll drill out the brake plate so the sleeve goes right through, and we'll bolt on this so that this is going to tighten up onto the sleeve and everything. The brake plate and this spacer can pivot on it, and that's better than it just being a 1/4 inch thickness there. That'll be good. Alright, let me, what I'm going to do, oh yeah, I've got to cut a bolt to that length so we can bolt it up tight. Right, we're all set. It's bolted up tight there and there, so that's exactly right. I've measured all these things, so now I'm going to tack this side, then we'll take the wheel out and we'll tack it the other side. Now while it's just tacked, what I'm going to do is drop the suspension units out of the top so we can lift the wheel up and down. Rather than bouncing it, we'll lift the wheel up and down. Sorry, just kicked the tripod there. Okay, let me get this tacked together. Alright, so that's bronzed on both sides. These are both tightened up, so the everything's being clamped up. As you can see, I've taken the suspension units out of the top. So let's see if this goes up and down without binding anywhere. That seems to me fine. So let's put these back in, and then we'll start making some measurements for the plate. Right, so what we need to know is the length of this spacer, which goes on there, and the distance from there to that, because that presses on the inside of the bearing. Okay, so what we're going to do is we're going to we'll put this in the lathe because we can grip on that. That's a nice surface to grip on. We'll open this out till we can slide a piece in, and then the piece we slide through when we clamp up the wheel spindle, that will clamp up against the bearing, but this will be able to turn on it. Alright, so let me measure that, and then we'll decide what size we want for things. Sorry, but you missed a bit. I had to turn the jaws around to get this in, and I sort of got carried away. I got it fitted and then I ran a drill through. So I took the drive part out of this, and there is actually a steel bush in there. So I've drilled that out to 3/4, and I've just turned that to be, let me put it on this way. Right, so this is the piece that's going to reach through from the forks to the inside, the center race of the bearing. So the next thing to do with this is I'm actually going to drill it and bore it, because it's a 12mm wheel spindle and I want it to be a really good close fit on this, because this isn't going to be turning, well, no, this isn't going to be turning, this is going to be clamped up, right? So let me drill it to something just under a 1/2 inch, and then I'll get the little boring bar out and do that to 12mm. Right, I've drilled this out to about 450 thou, and now I'm going to take it out a bit at a time to 470, trying it on the, where's it gone? There it is. Trying it on the wheel spindle when we get close. Now of course, 2 inches stick out on this to fit into a 1/2 inch bore is going to be quite a few spring cuts. So I'll just do it a little bit of time, won't bore you with showing you all that, and then I'll bring you back in a few minutes, hopefully. So what we're going to do is the old-fashioned method before we had DROs. Well, in fact, it's before I even had a lathe. So we are going to just face that end off. We're cutting off two. Right. Then we are going to measure that. Two. 2203. 2203. Oh, I haven't even got a pencil, look. 2203. Hang on. Okay, so I wrote that down and deducted it from the length I want it to be, and we've got to take off 150 thou. So we know that's touching right on the end. So we bring this along. Set that to 0. There's 100. And 50. Lock that down, and now I just take that off, and it should be the right length. I'm going to have to move you so I can get at the controls. Alright, there's what we were aiming for, 2.050. Oh, come on, Cam. 2.0505. That'll do me. In fact, that'll do me for the day. I'll see you tomorrow morning. So the last bit in the lathe is to take this spacer, which is the one that goes up against the brake plate, and bore it out so that'll slide on that. And this is what we're going to weld the plate to, the 1/4 inch plate to, that's going to carry the end for the cable. So let me just do that. Alright, so that is now a nice sliding fit on that. Okay, so while I've got this off, and that's the 1/4 inch spacer I used, I'm going to measure the diameter of them, because to get the center to center hole, it's going to be the radius of this one and the radius of this one, plus when they're on, I'm going to measure from there to there. Okay, so let me do that, and then we'll go and put the wheel back in. So now we come to that always exciting part. Did Michael measure it right? Okay, so that goes in there. That goes on there. It looks as if that might be a bit long. And let me wind this down. bit more. Goes in there. Now the question is, does this spacer go in the other side? Which it does, Big John. Now this is the big thing. There's the wheel tightened, and that still spins. So, next thing we put on is that like that. Put that bolt in a minute. And I've got a 3/8 bolt in this, and the nut is slightly bigger than an 8mm one, which is what the sort of little captive lugs are for on the other side. So I had to slim down a nut. So now that goes in there. Right. So now, as I say, we're going to measure from this bush down to that bush, and add that to the two radiuses of these two bushes, and we've got the distance between that and that. So let me do that. I really had to scrounge around to find a 1/4 inch piece of plate. I had lots of 3/16, but anyway, the bottom we have the 1 inch hole, so that'll slide onto that alloy spacer to which we will weld it. So what I've given myself is 1/4 inch around it. Then from there to there is the hole center. That's going to be a 3/8 inch hole. The reason it's offset is I'm maximising this plate as much as I can. So that's a 3/8 hole with a 1/4 inch around that as well, just to be on the safe side. So what we're going to do is hole saw that, drill that, and then put this on, and then decide where we're going to put our end stop for the cable. We'll have to make that. But when we know where that's going to be a 3/8 hole as well, actually, to make it nice and sturdy. Then when we know exactly where it's going, we'll do a nice, as I say, I was going to do it sort of L shape, but I think what we'll do now is we'll go across and make it in a more of an angle shape, and then put a couple of holes in it to make it look nice, and it'll still have the rigidity. What's it going to be? Is it going to be torsional stiffness or what? For because the pull is going to be that way across it. It's not going to pull it in or out, it's going to pull it downwards. So that's why, rather than being an L shape with an arm sticking out, we're going to have material down here, so those forces pulling on it will be transferred there, be nicely triangulated. So let me do these holes and then we'll fit it on. Well, I just had to sit down then. I went, oh, all strange, because look at that, the holes actually line up. I'm on the thing at the bottom and that is in there. Maybe I'm finally getting the hang of this measuring lark. Anyway, not exactly a lorry, but so the next thing we've got to do is decide where, well, first of all we're going to decide where the hell it is, but we've got to decide where the brake arm goes. What the hell have I done with it? Oh, there it is. Because that is going to go inside there. Yeah, there's plenty of space. Good. So, anyway, let me put this on and we'll look at that. Right, so there's that on there. So the first thing we've got to make sure is it's not going to catch on anything. Let me see if I can put it on round another one, because I'm trying to get the cable to be angled that way a bit rather than straight up and down. So get that off there. Fiddly. And then move it round a little bit to another spline. Come on to another spline. That's fine. Now that's going to go. This is just in the way. That's why I've got to take the bolt out. There. Go there. Let me put the little slimmed down nut in there so I can tighten this up. Right, so I might have to lower it down anyway because I don't think I've got enough. Unless I think of something different, let's actually put it. I see, really that wants to be up there. Oh. I was thinking this needed to be more out here, but it doesn't. It actually needs to be more up there. Let me give this a bit more looking at. So I found another piece of 1/4 inch alloy, so that's actually welded in to extend it. I kept the V as well and matched it up with that, so rather than just having a straight butt joint, it's in that V, and I really chamfered both sides so that it's fully welded. So what we're going to do now is make a piece that goes on the back for the cable to go on, and then when I know where that's going to be, we'll decide on the shape of this and get ready to weld it. Right, we're going to make this out of 5/8 round. I've turned down 9/16 here to 3/8. The 9/16 is just enough, for the 1/4 inch of alloy, a washer and an eye-lock nut. And I'm going to cut the 3/8 thread on this just with a good old what's it? With which that wants to be up there to act as the stop for this. There, and then we'll use that to hold it square. Cutting oil on it. Got it turned down to actually the lowest speed this will go. So let's see if we can just get it started anyway. Got to grip it a bit more. Well, that's handy, it came round to the right spot. There we go. I think that was turning, but I didn't have any pressure on it. And we don't need any thread for that 1/4 inch because that's where it's going to go through the thing. So let me take this out and we'll go to the mill. So there's that bit turned down and threaded. So what we're going to do now is put it in a collet block. Just put a flat on one side, we only need it on one side, flat on one side, and then drill a 5/16 hole through it for the adjuster to go through. Suppose I could thread it. Yeah, we'll do that. We'll thread it. The adjuster's a 5/16 UNF. So I've got to see how far out from there I need to be for the cable to have a nice straight run down to the brake arm. So let me just go and check that. So I've milled the flat on and marked where I want my hole to go. That's that done. This is the tapping size for 5/16 fine. That's the one thing I forgot to get out with the chamfer tool. Ow, and I can't get it out with you there. Hang on. Right, you were just in the way of the draw. And last but not least, we will just give this a little start. Actually, it tapped. Alright, let's go and see where that goes on the bike. Alright, where are we? There's the piece finished. So that just goes in there. Threads in that like so. Okay, right, so let's see where it needs to go on this plate. Now this doesn't have to be absolutely exactly right, but I want that to be about could do with two hands here. I want that to be at right angles right to its maximum pull. I might get my head in the way here. So I think it wants to be about there. That's why I put some red on this side, see, so I could mark it. There we go. Alright, so let me drill a hole in that and then we'll see how it works and then we'll shape the plate. Alright, so I'm just going to use an ordinary nut on this side because, as I say, I've made it for a lock nut. But tighten it up, I can just do it back with my fingers here since it's not a lock nut. Alright, so that's going to go about like that. Don't forget, this will be easier when it's cut down to size. I should have screwed that in before I put it in there, shouldn't I? There it goes. I'm going to shorten this cable a little bit. Very good. Let me tighten that up to where it should be. About like that. Very good. You see that? And you can't even see that working, can you? Now then, so we'll put that back like that. That'll be fine. Okay, let me mark the other side. And there it is, all shaped up and ready to get welded on. So let me bolt all this on, get everything cleaned up, then we'll tack it in place, take it off and weld it up properly. I don't think I'll put a hole in. I think that looks fine as it is. Alright, there it is, all on. Welding down here is crap. I don't know what happened, I could not get a clean puddle. Cleaned and got a piece of this alloy that I'd used and a piece of the alloy for that and tested on them. They both welded perfectly. But there's something in there that keeps coming out. I don't know. Anyway, it'll do for test riding, and then I'll have to take it off and grind the weld out and redo it because I don't like it. So, brake works. I've got to shorten the cable because I've got all the adjustment here and up at the handlebar taken up. Needs about ½ an inch cable taken off. Right, before we finish the day, let's get it down and see what happens. Alright. Brake on, push. That's it. Feels like there's something loose in there. It must be just the way it works. Anyway. Oh, straight up and down is so much better. Never mind the fact that it goes down when I just push forward. Alright, I'll get it all put back together tomorrow, and if it's not raining we'll have a quick gallop round, or to the cable, we'll have a quick gallop round and see what happens. Alright, see you tomorrow. Alright, let's give this a go. As normal, there will be road noise. So as you saw, it works really well. I mean, you couldn't tell much from me riding it before I did the floating brake, but believe me, it feels a lot better. Works very nicely, and I have actually been out and done a couple of loops since I did the mod, and we filmed this little bit. So yeah, I'm very happy. That's project well done, well sorted, and all we're going to do now is wait for the next project. Until then, stay safe and enjoy yourselves.